Hello student, hi, good afternoon. So today we are going to discuss about pin diode. Okay, so this is my pin diode. Pin diode. Today we are going to discuss about pin diode. This is my pin diode. So if you see what is pin diode, what is pin diode? So pin diode is nothing but it is a like if you see this is the symbol of pin diode is similar to general PN diode. So this is my anode and this is my cathode. Cathode. This is my cathode. Anode cathode. This is P side and this is my N side. And this is my intrinsic side. Intrinsic. So pin diode means it is this is my P region, this is N region and this is I region. I region. And this is my anode and this is cathode and this is anode cathode. Okay, so now see what is P, what is this pin diode? Actually pin diode, if you see, this is what P region. It is heavily doped P region and this is heavily doped N region. Okay, P region, N region. Between this is what intrinsic region. This is my intrinsic region. So intrinsic region. Now we will see what in pin diode. In pin diode, first of all, we will see intrinsic region, because if you will eliminate this intrinsic, then it becomes similar to PN diode. Okay, PN diode. This is my normal diode, PN diode. Okay, so if we will emit this, okay, if we will eliminate this intrinsic region, it becomes normal diode. Okay, so now what is the main important feature of this intrinsic region? What is the main? Okay, so now we are going to see what we are just, this is just a symbol. Okay, this is just symbol for what? Pin diode. For pin diode. Okay, symbol for pin diode. This is just symbol for pin diode. Now just wait. If you see here, what we are going to see, we are just going to see what is the main purpose of that intrinsic region. If you see this, what is the main purpose of intrinsic region? Okay, so just you listen. So this is my P region and this is my N region. Okay, this is my N region and this is my intrinsic region, and this is my cathode and this is my anode. Okay, anode. Now what is the main purpose of this intrinsic region? Intrinsic intrinsic region. Intrinsic region. Okay, so this is what intrinsic region, and this is P. P means P means what? Trivalent impurity. Okay, so this is what? Trivalent impurity, and here we have doped trivalent impurity, and here we have doped pentavalent impurity. Okay, pentavalent impurity. Intrinsic region is what? It provide what? It provide the larger undoped region. Okay, so this is my undoped region. This is my undoped region. Undoped region. No doping is there, so it is a pure. Okay, it has a charge carrier, but those charge carrier are immobile charge carrier. Okay, and hence it is acting like insulator between these two doped region, between this doped region. Okay, so it is acting like a insulator. So therefore this intrinsic region provide what? Intrinsic region provide the large resistance between P and N region. Large resistance between P and N region. For that, first of all, we are going to see first feature. What is the actual feature of this intrinsic region? For what purpose we are using this? Okay, so there is some purpose, so that's why we are using this intrinsic region. First is what? It provide what? It provide high. It provide what? Large resistance region. It provide large resistance. It provide large resistance section. Large resistance section between heavily doped P region. Between heavily doped heavily doped P and N region. Between P and N region. Just wait. So first feature is it provide large resistance section between heavily doped P region and N region. Once it provide large resistance means what? Large resistance, it provide large electric field. Okay, so which means what? There is a large electric flux. Okay, so there is a large electric field, or you can say electric flux. Yes, there is a large electric flux means field line. So there is a existence of large electric flux. Okay, from large electric flux from where? From n region to n region to p region. N region to p region. If you see this n region to p region, it provide what? So there is a establishment. Yes, there is a establishment of what? Large electric field or large electric flux from n region to p region. This electric flux means field line. Okay, if you say electric field, that is single electric field. Single electric field. If you will say electric field, that is single electric field. If you want to say electric flux, means there is a lot of electric field lines. Group of electric field lines is nothing more than electric flux. Okay, so these electric flux will get established from n region to p region. Why n region to p region? Why not p region to n region? Because as we know very well, electric field will always electric field will always direct from higher potential to lower potential. Yes, positive to negative. If you see here, this is what? N means what? Pentavalent impurity. Doping of pentavalent impurity. Pentavalent impurity, like say phosphorus. Phosphorus has how many electrons in its outermost shell? There is a 5. Yes, 5. When we will dope this with silicon, so then there is one excess electron. One excess electron means what? It can easily donate this electron. Easily donate means what? It is a donor type. It is a donor type. So that's why what? That's why it has positive charge. Positive charge means here means it is a donor. Okay, donor atom. So similarly here P is what? P is a trivalent impurity. In P region there is a trivalent impurity. Trivalent impurity, let us say aluminum. Aluminum has how many electrons? 3 electrons. When we dope this with silicon, so then there is a total 7 electron, and we need one more electron. So therefore, to make the full octet, so that it becomes stable, so for that it need one more electron. Okay, so means there is a deficiency of one electron. Deficiency of one electron means it need to accept one more electron. Acceptance means what? Accepting means what? Negative charge. Okay, so therefore this negative indicate what? Acceptor. Okay, acceptor. So therefore there is a establishment of electric field from higher potential to lower potential, from positive to negative. So therefore there is a group of electric field, like so many number of electric field is there from n region to p region. That number of electric field is nothing but electric flux. Okay, electric flux. So it will, but there is a establishment of what? Large electric flux from n region to p region. Now this electric flux, what? Electric flux produce what? Electric flux which produce the large number of electron and hole pair. Okay, electron and hole pair. So this is what? Which produce just wait. Which produce large number of which produce large number of and hole electron and hole pair electron and hole pair. Yes, which produce a large number of electron and hole pair, and hence we can say that therefore this pin diode process even though weak signal. Why? Because of this large electric flux. Okay, so this large electric flux, hence we can say that it can. So therefore this pn this pin diode this pin diode this pin diode this pin diode can process can process this pin diode can process even weak signal even weak signal. So therefore, this pin diode can process even weak signal. This is what first feature. First feature about intrinsic reason. Okay. So because if you will eliminate this intrinsic reason, then it is nothing more than simple PN diode. Okay. So it is very important in this pin diode to discuss about this intrinsic reason. What it has different type of feature. So first type of feature we have found. What type of feature is there? So this is the feature is that this pin diode is able to process even though the weak signal. Why? Because of this large section of intrinsic reason. So this intrinsic reason provides what large. It is a large section of resistance. Yes, it is a large resistance section of large resistance, and therefore there is a establishment of large electric field from n region to p region, or you can say there is a establishment of large electric flux which will generate what large number of electron and hole which will generate large number of electron and hole pair, and in this way we can say that this pin diode is able to process even though the weak signal. This is one type of feature that we found in this pin diode. What is next feature? We will see this. Let's see. Next is what? Next is like as a capacitor. Okay, so it has a feature like capacitor. So capacitor. Okay, capacitor like feature. Feature is available in pin diode. During reverse bias. So from here what we can say that here capacitance like feature. So you see this intrinsic reason. Okay, intrinsic reason, it is undoped reason. Okay, it has charge carrier, but those charge carrier are not moving. Those are what immobile charge carrier, and hence we can say that it is behaving like what dielectric constant. It is behaving like insulator between p and n region. So therefore p and n region. So in reverse bias, if we see during reverse bias of this pin diode, as we increase the reverse bias voltage, this distance will increase between p and n. This distance of intrinsic reason will increase. Okay, it will increase until and unless all the charge carrier will get swept out from this intrinsic reason completely. Okay, so it will increase. So therefore, if we see, if this d increase, okay, if reverse bias voltage, let's say reverse bias voltage increase, which implies distance increase. Distance increase means capacitance decrease. Because as we know very well, C is equal to epsilon A by D. Yes, A by D. So this is what A by D. So therefore, if you see, C is equal to epsilon A by D. If you will increase D, if D increase, C decrease. Okay, so this D increase because we are increasing reverse bias voltage. Reverse bias voltage increase, D decrease, D increase, capacitance decrease. Capacitance decrease. Here is the important point. This is what time constant. Time constant is what R into C. R into C. If C decrease means time constant decrease. Time constant decrease means speed. Time constant decrease means here is relation between what bandwidth. Bandwidth is equal to 1 by time constant. If time constant decrease means bandwidth increase. Bandwidth increase. Okay. Here again bandwidth is proportional to speed. What speed? Proportional to speed. Yes, this is proportional to speed. Bandwidth is proportional to speed. Okay, so this is proportional to speed. Now speed. If bandwidth increase means speed increase. Speed increase. Which speed of this pin diode? So switching speed increase. So therefore time response will get improved. Time response will get improved because of this intrinsic reason. Because of this intrinsic reason, therefore switching speed of the device or switching speed of this pin diode will increase. This is one of the another special feature that we are getting due to this compression of intrinsic region between P and N region. Between P and N region. Okay, so these are the two features that we have seen. First is what? First feature that we have seen that it is able to process the weak signal, and second we have seen that it provides very high speed switching. High speed switching. It provides high speed switching. Why? Because of intrinsic section. This intrinsic region has large area which provide large distance, and hence it provide less. It provide very low capacitance. Very low capacitance. Once the capacitance is very low, then this time constant is what? Low. This time constant is low means what? Low means bandwidth is high. Bandwidth high means speed high. Speed is high. So therefore speed is high. Therefore it is what? It is appropriate for the application of high frequency signal like microwave. Okay. So it is applicable for what? It is applicable for high frequency signal like microwave case. Okay. So this is the second feature that we have seen. Okay. We have seen two feature in this because of this intrinsic reason in pin diode. Intrinsic reason in pin diode. Okay. So now coming to next one. Next one is what? This is intrinsic reason. Okay. So now see intrinsic reason. The main important feature also that intrinsic this pin diode has what? Pin diode has storage of charge carrier. This intrinsic reason, this large intrinsic reason store the charge carrier. So therefore which is responsible for the current flow through the circuit. Current flow through the this pin diode. Okay. So pin diode. So third feature is what? Storage. Third feature is storage of charge carrier. Storage of charge carrier. Third feature is storage of charge carrier. So this intrinsic reason store the charge carrier which is responsible for current. Yes, which is responsible for current through pin diode. Okay, pin diode. So therefore if you see pin diode, when this current will flow, so during forward bias, when we provide the forward bias voltage, so that time what happen? That time this depletion region will start decreasing. Okay, once this depletion region will start decreasing in forward bias case, then that time as we increase the forward bias voltage, depletion resistance decreasing, then the resistance of this region decreasing. So the resistance of this region also decrease. Okay, as we increase the forward bias voltage, from there what we are able to see, what we are able to observe, we are able to observe that the resistance of this intrinsic region also decreases. So in this way we can say that it provide what resistance, variable resistance feature. What type of feature? Variable resistance feature. So the third third feature is what? This is what my third feature. Third feature is what? Storage of charge carrier. Storage of charge carrier, which is responsible for the current through the pin diode. And when we will make this pin diode in forward, when we forward bias this pin diode, that time what happen? That time this depletion region will start decreasing. Yes, depletion width decreasing means what? Depletion width decrease. This depletion width will get decreased, so therefore the number of charge carrier, okay, charge carrier, free charge carrier will also get reduced, and due to which the resistance that this intrinsic region has will decrease. So therefore, as we increase the forward bias voltage, resistance decreases, and in this way it will provide us what? Provide us voltage means resistance variable feature. So therefore it provide resistance 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 variable resistance variable feature during forward bias, during forward bias during forward bias. Yes, so that we have that now we have seen what three feature. First feature is what? This pin diode is able to process the weak signal, and second feature we have seen that this pin diode provide high speed switching, so therefore which is suitable for high frequency application, and hence it is appropriate for microwaves. Yes. Now third feature we have seen that during forward bias region it provide variable feature. It provide resistance variable feature. As we increase the forward bias voltage, resistance of this intrinsic region decreases, and hence it is a region resistance variable feature that we have obtained. So now this is my third feature. Okay, so now if you see fourth one, what we can found here, fourth one. If you see fourth one is what? Fourth one. Now see what is the another reason for this intrinsic reason. See, this intrinsic reason provide large area. This intrinsic reason provide large area to the radiation large area. Okay, so through which the radiation contact the surface. Yes, through which the radiation contact the surface. Okay, so this is what the intrinsic reason provide the large area for the radiation absorption. Whatever the radiation that is coming from the sunlight, so that it will get absorbed within this large area, and hence we can generate a lot of charge carrier within this depletion region, within this intrinsic region. So therefore, fourth feature is that the intrinsic region it provides a large area for the radiation absorption, and hence it is employed as what? It is employed as photo detector. What is photo detector? In photo detector, it convert. Okay, so in photo detector it is used for the transformation of light energy into the electrical energy. So light energy into the electrical energy. So photo detector, you see here, photo detector. Photo detector means what? it convert light energy. It convert light energy. Yes, convert light energy into electrical energy. Light energy coming in the form of photon. Yes, from the sun. photo detector. Photo means photon. Photo means photon. Photon. Photon means what? Photon. So group of photon is nothing but light. Yes, light. So photo detector. By detecting photon, by detecting photon means by detecting light energy, it will get converted into electrical energy. Yes, electrical energy. So so this is like light. So that is what sunlight. Sunlight is coming with the energy of photon. Let's say energy of photon is equal to h nu. Is equal to h nu. H nu. Yes, this is my energy. Energy. If this energy cross the threshold of energy band gap, energy band gap. Once this energy is less than energy band gap, then the mobile charge carrier that is present within this intrinsic region will get what? Will get ionized. Okay, so we'll get what? They will get free. Means whatever the charge carrier that is immobile charge carrier within this intrinsic region. So which is so they are getting the energy, enough energy, and they are able to break out this covalent bond, and they will get free. Okay, so in this way we will get what? Lot of charge carrier within this depletion region. So this is one of the important feature that we are getting in case of pin diode. That is photodiode. Photodiode. Photo means photon, light. So that will get converted into electrical energy. Means there is a transformation. There is a transformation of light energy into electrical energy. When the photon will get stuck into this content, into this surface of this intrinsic region, that time whatever the charge carry, that is immobile. Okay, immobile, so they will get excited by this photo, and they will gain some amount of energy, enough energy. They will gain enough energy, and they are able to break out the covalent bond and become free. Yes, become free, and hence in this way the current will start flowing through this device. Okay, so this is for photo detector. And the condition is that whatever the energy of photon that should exceed this threshold point of what? Energy band gap. Once it will cross the energy band gap, means it should be less than energy band gap. This energy should be greater than energy band gap. Okay, energy band gap. And in this way those charge carrier which is bound with in this depletion region are able to what? uh, Able to break out the covalent bond, and in this way they will get free out. Okay, free. So this is what? Photo detector. So now fourth, if we will see this fifth one. What is fifth one? So this is the last. Yes, so this is what about these. There is four feature that we have seen. What is first is about the pin diode that is able to process the weak signal. Okay, process weak signal because of this intrinsic reason. Okay, and second that we have seen means this pin diode, it provides fast switching. Okay, it provides fast switching, so therefore it is used for the high frequency signal. So like in case of microwave. Okay, because of this intrinsic reason only, because it improve the time response of this pin diode. Yes, so because of capacitance. Yes, as we increase the reverse wise, then this depletion region width will increase, capacitance will decrease, capacitance decrease, time constant decrease, bandwidth increase. Once bandwidth increase, speed of the response automatically increase. So switching speed increase, so therefore it is used for high frequency signal. So and third third that we have seen what? Voltage, that variable resistance feature, that we have seen the variable resistance feature in case of forward bias. When we make this forward bias, this PN diode, then that time what happen? This depletion region will start decreasing. Once it will start decreasing, then the resistance will start decreasing. Yes, that depends on the whatever what amount of forward bias voltage you are applying. So in that way, this resistance will start decreasing, and hence it provide variable resistance feature. So now this is my fourth one, photo detector. Photo detector means this intrinsic region, it provides the large area. So within this it provides large area for what? It provides the large area for radiation absorption. radiation absorption. Okay, as the photon strike this surface of this intrinsic region, so therefore the charge carrier will get the charge carrier which is in unbound, which is what immovable within this intrinsic region, will get enough energy to break out the covalent bond and come out of the bound state, and in this way the charge will get free. So therefore it will work as a photo detector. Photo means photon detector. So therefore it is a transformation of light energy into electrical energy. So these are some features that we have seen in case of photodiode. And the main application of this spin diode, that is like application. If you see the application of this spin diode, application of this spin diode, if you see, this is high voltage rectifier. It is used for high voltage rectifier, and second is photodetector, and third it is used for radio frequency signal, okay. So high frequency signal, high speed switching. So these are some application that we found in case of pin diodes. Okay, so now we have seen proper what is the main purpose of this intrinsic region, because without intrinsic region, so it has same similarity. It is similar to PN diode. If we will remove this intrinsic region. Okay, so why intrinsic region? Because of there is some different feature that we get from the due to this intrinsic region. Okay, so that we have seen four important feature. Okay, so and also it provide the high voltage, it provide high breakdown voltage. Okay, so and also it bear the large breakdown voltage. Okay, so therefore it improve the breakdown voltage. This pin diode also improve the breakdown voltage. So these are some important features that we have seen in case of pin diode. Okay, so that's all about this pin diode. Okay, so next we will come another new type of diode like Zener diode. Okay, so that's all for today. Thank you.